Alright, so this video is going to be part 2 of our alternating series test practice. Okay, so we want to determine if the series converges or diverges. We have the series right up here, the sum from n equals 1 to infinity of -1 to the n times n squared over n squared plus 1. Alright, so the first thing we need to do if we want to use alternating series test is figure out that b sub n. Okay, and to figure out that b sub n, we just take away this -1 to the n, right? That's what's making this alternating, so that's what we're going to take out to get our b sub n. And that gives us n squared over n squared plus 1. Okay, all we did was remove that -1 to the n. Now we have b sub n, so there's two conditions now that we have to meet, right? Just like in the part 1 video. Right? It's got to be decreasing, and the limit as n approaches infinity of b sub n needs to equal 0. Alright, so first we need to figure out if this is decreasing. Okay, is it decreasing? So we can just write n squared over n squared plus 1. And as we increase n, well, let's increase it by 1. N plus 1 squared over, this is now an n plus 1 squared plus 1. That's going to be equal to n squared plus 2n plus 1 over, this is now going to be a n squared plus 2n plus 2. At this point you may be wondering, like, okay, how am I going to see if this huge thing is going to be less than this? Well, just plug in a number. Alright, let's plug in 1. Okay, so first off we have n squared, that's just going to be 1, over n squared plus 1, that's just going to be 2, right? 1/2 here. Okay, we just plugged in a 1 for n. Now over here, we have a n squared, that'll be 1, 2 times 1, it'll be 2, plus 1, and we'll get over a 1 plus 2 plus 2. And that is equal to, well, we have a 4 on top and a 5 on the bottom. Okay, so you can see that this isn't decreasing because 1/2 is actually smaller than 4/5. Okay, so there's a problem, right? This isn't decreasing. Okay, and if you took the limit, you would also see that the limit as n approaches infinity of this doesn't equal 0, it equals 1. Okay, so you run into a problem because neither of these conditions are being met. So what do you do now? Well, I'm mainly showing you this problem just to prove a point, okay? With this acronym that I wrote up here of all our tests, right? You start off with the test for divergence, our D, okay? So that would be the first thing that you would do to this, okay? You can prove that this is divergent by using the test for divergence. So let's see that in action here. We take the limit as n approaches infinity of -1 to the n times n squared over n squared plus 1. Well, this -1 to the n, that's not going to really matter at all here, okay? Now, we're left with an n squared over n squared plus 1, and we know that that's just going to equal 1. And that's not equal to 0, so we know that this is divergent by the test for divergence. Now, I know that this is alternating series test practice, but you have to go through, and we'll talk about this more when we actually, we're not focusing on a specific test, but you can prove that something that looks like this is an alternating series, but if that alternating series test isn't working, it's most likely because you haven't tried a test before that, right? Like the test for divergence, okay? That's something that will work for this series, okay? That's what you do before you get to the alternating series test, right? It's before the A, right? D is coming before A, so try that first. So we're going to talk about this more later on, okay, not in this video, more about when we look at a series and we need to pick a test, okay, but alternating series test is not the only thing that will work for an alternating series, okay? You also have the test for divergence, okay? And that's all going to come when you do the little process that I'll have laid out for you, okay? The first thing that you're going to do is, of course, always the test for divergence. And here, if you would have done that, instead of immediately jumping to alternating series test, you'd already be done, okay? So that's basically the whole point of that. All right, so for our next series here, we have the sum from n equals 1 to infinity of -1 to the n times n over n cubed minus 1, okay? So we need to figure out our b sub n, and that's just going to be the series without the thing that's making it alternating, which is that -1 to the n. So we're left with n over n cubed minus 1. All right, cool. So now we need to see if this is decreasing. All right, let's see if it's decreasing. We have an n over n cubed minus 1 compared to a n plus 1 over n plus 1 cubed minus 1. All right, so we're showing an increase in n here, right? If that doesn't make sense to you why we're adding 1 to it, that's why we're showing an increase in n. So we need to see what happens to it. Well, you can kind of see here that, you know, we don't even need to end up doing that 3 times, right, and multiplying that out. We don't need to do that because you can kind of already see here that since this is cubed, right, on the bottom here, if you put any change in this n, okay, we're adding 1 here, there's going to be a lot more of a change than on the top. You're just adding 1. Well, here you're adding 1 and then you're cubing it. So there's going to be a lot of change here. So your bottom is just going to get bigger and bigger and bigger compared to your numerator. And that means that this will be increasing, okay? Because if the denominator is bigger, well, that means that this is going to be a smaller fraction overall, okay? So we know that it's decreasing. We can check that off right there. Now, is the limit as n approaches infinity of that b sub n equal to 0? Well, limit as n approaches infinity, that b sub n is n over n cubed minus 1. And again, you can do L'Hopital right here if you really want to. It actually might be a little bit quicker than dividing everything by n cubed here. Up to you. You can get a 1 over 3n squared. And of course you have to put your limit notation in. Don't forget that. It's easy points off. So you see as n approaches infinity here, this is going to equal 0. All right, as n gets, you have an n squared in the denominator here, so as n approaches infinity, you get an infinitely large number on the bottom, which of course means that your limit equals 0. So it passes both our conditions. That means that this series converges by the alternating series test. And that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the alternating series test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.